All right. Good evening, everyone. It's 6 o'clock, and it's our June ACM Chicago webinar, our second one that is hybrid. So welcome to those who are in person at the Loyola University Cuneo Hall, room 2, and welcome to those that are joining us online. So tonight we have a very special speaker. I know him very well, Jorge Coca from Very Good Ventures. And he's going to talk about Flutter, 0 slides and all code. So hopefully by the end of this talk, if you don't know about Flutter, you will know about Flutter. And just a little bit of introduction. So we welcome those members from IEEE Computer Society Chicago. So I'm the chair of that. And we do lots of events that are joined together with ACM Chicago. And we have our YouTube channel. We have our social media channels. And of course, members from ACM Chicago. So if you know ACM Chicago, it's the Chicago chapter of the Association for Computing Machinery. So it's a computer professional organization. We've been doing monthly meetings, virtual during the pandemic. I think our last actual meeting was actually in Loyola. I think it was actually, it might be even in the same room that Jorge, you guys are in there. It was in February of 2020. And then we switched to everything in virtual. And then we had our first in-person also in that same place that you are right now in last month. So I'm the chair. Our vice chair is Mark Temkin, who is in the room. And also our treasurer, Greg Newmark. So we have our meetup site. So most of you probably got this meetup from the meetup site. We also have our webpage, Facebook, Twitter, LinkedIn, and our YouTube video. So subscribe to our YouTube video channel so you can get the latest and the previous recordings of our events. And so for tonight, the reason why you're all here is to listen to Jorge Coca. So he's the head of engineering at Very Good Ventures. And actually it's interesting because he used to work for BMW. So we worked together before in the technology office in Chicago. And actually he was the one that actually introduced BMW to using mobile development with Flutter. So that was Jorge. And so a little bit about himself. He's a Spanish engineer lost in Chicago. His passion is to help teams of all sizes to be successful in their Flutter adventures. And like I said, he previously worked at BMW, leading the Android and Flutter practices. And he's also a Google developer expert in Flutter. All right. So without further ado, then I will hand it over to Jorge to talk about Flutter. So go ahead, Jorge.
All right, thank you so much. I think that we're still trying to connect here in the room in Chicago. I'm gonna try to do my best to talk about Flutter without having to jump too much into the code so everyone can follow along. I'm gonna share my screen very quickly. I'm gonna talk a little bit about Flutter and what it is, but in reality, what we're gonna be doing during this entire session is pretty much like coding. We're gonna get to practice Flutter code. We're gonna see probably that if you have experience with Java, with JavaScript, with TypeScript, with C#, congratulations, you know actually Dart, the language that powers Flutter. And we're gonna see how with just a very few lines of code, we can actually do a lot of work with Flutter. But let's start for the basics. What's Flutter? Flutter is just a UI toolkit to build applications for any screen, whether it's iPhone, like Android, your Mac computer, your Windows computer, your Linux machine, but also like other systems like your vehicle, for example, your navigation system, your like instrument cluster behind the steering wheel, right? Or if you have a smart fridge that has a screen, you could also be using Flutter over there. Or imagine the Jumbotron of a stadium, right? Pretty much anywhere where there's a screen, you should be able to run Flutter without any problem, right? More importantly, and if we go to the pure definition, Flutter is an open source framework. So if we go to GitHub and we search Flutter, You can see the entire development, the entire roadmap of the system, right? It's developed by Google to build beautiful, natively compiled multi-platform applications from a single code base, right? This is kind of revolutionary compared to other technologies, right? Like React Native or Xamarin, in which part of that experience is processed at runtime. Here is very important to understand that Flutter actually is natively compiled, right? So your binaries, your ones and zeros that the computer will know at the end of the day, they're kind of like very similar to what you would produce from Java or from any other kind of like native languages, right? One thing that is quite interesting as well, right, is that even if you don't know, probably you have some devices already that might be running Flutter or something similar. If you have at home one of these smart devices like the Google Assistant with the screen, for example, that's running Flutter. But actually, because Flutter is a painting framework, it's kind of like a stripped version of Google Chrome. What do I mean by that, right? Google Chrome as a browser, at the end of the day, is just a rendering system, right? Like it renders HTML really well. So very smart engineers at Google, what they do is to take all the rendering logic and remove all the browser noise that comes with Google Chrome. So they could have a very efficient painting system. And then on top of that, they added like an API that is based on widgets, like tiny UI components that we lay out on the screen. And that's what they call Flutter, right? Flutter, as I said, like it's inspired by that. It's kind of like stripped version of the rendering engine of Chrome that it's called Skia, and that's like the foundation of the framework of the system, right? Flutter is used by many companies all around the world: BMW, MGM Resorts, American Airlines, the New York Times, Toyota, right? For all kinds of systems. Even most recently, if you follow along the news, Ubuntu is actually running many of their native applications using Flutter. So the next time that you go to Ubuntu and you go to the Ubuntu App Store and you search for an app and all that stuff, all that is going to be written in Flutter. So with that said, I'm going to show you. All right, it seems like now we're presenting on the screen as well. So now the people in the room can see as well. So now I can actually show you what we're going to be building tonight. And what we're going to be building tonight, we're going to be using dartpad.dev. So if you want to follow along in your browser, you can do so. This is the beauty of Flutter, right? It runs on any screen, even in your browser. So we're going to be using this dartpad.dev website to build the code on the left, and we're going to be running our project on the side. I'm showing you right now the entire solution. We're going to be building galaxies, right? Because galaxies are pretty, they're beautiful. And pretty much how our galaxy is going to work is that every time we tap this button, we're going to see a random generation of different stars with different colors and different sizes, right? And this is animating like about 100 objects at the same time without any problem, right? This is one of the beautiful things about Flutter. It runs at 60 frames per second. You as a user, you will never be able to tell if you're running a Flutter app or a native application, right? That's what makes Flutter so beautiful. So let's get started. Let's gonna take a look to the code very quickly here. And as I said, if you've seen Java in the past, if you've seen TypeScript, if you've seen C#, there are gonna things that are gonna sound very familiar. So we're gonna review some of these concepts, and then I'm gonna delete the entire code, and we're gonna start from zero. All this entire project is built with just 120 lines of code, right? So as you can see, we can build very complex and beautiful things in just a few lines of code. Where do we start? With a main method, right? Like any other type of application in the world, our entry point to the software is going to be our main method, right? It returns a void. It doesn't do anything. It just runs our application, right? And Flutter is going to use this method called run app to inflate our widget. In this case, our entire application is a widget, but also every single tiny circle that we see in here, this button is a widget itself, right? Every single piece of user interface that we put on the screen with Flutter, it's going to be called a widget, right? And in this case, our first application, our first widget, it's called application. And the way they relate each other is through a tree structure, very similar to what we see on web with the HTML DOM, right? In Flutter, we're gonna have a tree structure that we call widget tree. Our top, like a root of the widget is gonna be the app widget. And then we're gonna see how underneath that we have the material app widget, the scaffold widget. We're gonna see what they mean in a minute, right? But things that are familiar from other languages, we have a class keyword, right? And it does what you expect. It's a class, right? And you can also inherit from other classes. So you're gonna use extends for extension, right? And we're gonna be extending from. Yes. Does this work? Yeah. Let's give it a try. Yeah. Okay. So now we tap on create a galaxy. Still works, still animates. We didn't break anything. Awesome. So we have our class keyword and we have our extends keyword, right? Extension means that this object, our app object, is going to be of type stateless widget, right? I said that every single piece of user interface that we're going to have in the screen is going to be called a widget. And we're going to have two types of widgets. Widgets that don't hold any data. They just paint things and they don't react to data changes. Those are called stateless. They don't have any state. We're going to have also a separate type of widget that they're called stateful widgets, right? And those are going to react to changes based on the data that they hold. So for example, in this case, we're going to be talking later about a galaxy state with many stars, right? And the properties of those stars are going to be changing. And as they change, we're going to be painting new animations on the screen. Therefore, we're trying to react to state changes. That means that our widget is going to be stateful, right? And things that we have in here, if you come in from Java, are override keywords, right? That's great. That means that we need to provide an implementation of this method called build that is going to return a widget, right? Piece of user interface. And it's going to be getting as an argument an object called context that is going to tell us where we are in the widget tree. This context, because it tells you where you are in the widget tree, it also allows you to look up in the widget tree and ask your parents information that might be available in the widget tree. Sometimes it's going to be what's the screen size or how much space do you have to paint yourself. Sometimes it might be information that you put yourself in the screen. So with just those few concepts, you're going to realize how much work we can do. So I'm going to start actually removing code. Let's remove all these. I know that it's not going to compile, but that's fine because we're going to start from 0. And we're going to do some exciting things. So the first one that we're going to do is actually just run an empty application. So if I click on run, what we're going to see now is that I'm going to have an empty image here on the right. There you go. It takes a little bit, but as you can see, what we have in here is an application widget. It's going to give us a widget. This material app is the material widget. We're going to be using a design language system called Material. If you have an Android phone and every time you tap a button, you see that rippling effect and all the stuff, right? That's coming from the Google design language system called Material. We could use, in this case, as you can see, the Galaxy doesn't have a particular like look and feel, but we're going to be using this one just to have a top widget tree with that material. So what we have after that is like we have set to false this debug show check mode banner. It sounds very long, but in reality, what that is doing is like if it's turned to true, it would show like a debug banner in here that is just very ugly, right? So we can ignore it. And then we're going to be using this scaffold widget. This scaffold widget is just to set up certain elements on the screen in a standard way, right? Like if you've seen like some Android apps, they always have like a floating action button on the bottom right and things like that. So that widget just laid out some of the elements, some patterns for us and all that stuff. And the body of our application is just a container because that container doesn't have any information. It's going to be empty, right? So let's add a little bit of information of this container. We're going to add a color, right? And we're going to add a child, right? Because it's a widget tree. Your nodes can have children. In this case, this particular widget container can have only a single child, right? But other widgets like column, like list views and things like that, they're gonna be the parent of multiple children. Therefore, they will have in their API children instead of child, right? And in this case, I'm just gonna remove this galaxy for now. We're gonna comment this, right? And instead, we're gonna build in a text that says hello. I'm gonna add a comma here. I'm gonna run again. I know that I'm getting like this import that math warning is not being used. That's fine. We'll get to that in a second. But now what happened is that we're using this color that it's very dark, right? Like that's gonna be the background of our galaxy. And guess what? Our text is also black. That's fine. We'll figure that out. But believe me, there's a text that says hello somewhere in here. What I want to be focusing right now is actually not to build more widgets. Instead, I want to build a model, right? We're going to be building a galaxy. That galaxy has multiple stars. Therefore, we need some sort of model, some sort of star object that can hold the data associated with a star. So we're going to start building that, right? We're going to create a new class called star. And this class is going to have one property. We're going to start very simple, right? We're just going to be changing colors and we're going to be building one single star. Because once we know how to build one star, make it bigger or smaller, right? Change its color, change its brightness. Once we know how to do that with one, I promise you we'll be able to do that with 100 or 200 or whatever is needed, right? So let's start simple and let's build a star that has a color property, right? This color property needs to be assigned its value in the constructor. So the way we're going to be using that constructor, right? We have a class. The constructor is just like a special method that has the same name of the class, right? So we build a star constructor, and then we're going to assign a value to color, right? And in reality, our stars, they can have 3 colors. So I'm going to be building a static property in here that I'm going to be calling colors, right? And the first one is going to be colors.yellow. This is all coming from the material library. So those colors are already set up by the system for us. I'm going to be using colors white and then colors orange as well. And I promise you, if I can remove these warnings over here, that it's here. And we're going to add that comma, and this needs to be colors. All right. And then, because those colors are going to be random, I'm going to be creating also a random object, right? This random object is not constant because it changes from time to time. So the way we create a random object is just like that, static final, right? So now we can do the rest of the work and assign our color field, our color variable, a value. How we're going to do that? Well, we're going to pick from the colors array that we just created, right, a random value. So we're going to go and call our random object, and we're going to pick one value from our colors that array, right? This needs to be plural. And then on top of that, I'm going to change actually the transparency. I'm going to be modifying the alpha channel of the color, right? So we know that this is a color object, and every color object has an alpha property. So we're going to be adding also like some randomness to our alpha channel over here as well, right? Because this is an RGB color. Its values from 0 to 256, right? So in this case, what we're saying is like just pick one value between 0 and 256, right? So now with that, we have our star object, right? This is not painting anything in the UI. It just holds the data that we need to build that, right? So now we can start building a little bit of our galaxy, right? In reality, what we want to do or paint in this screen is not this text hello that actually we cannot even see. What we want to build is a galaxy, right? So let's build this galaxy. And this thing is not going to compile. I know that, right? So, okay, we'll get to that in a minute. What we need to build, right, is that we need to create a new widget, right? Because we're going to be painting on the screen this galaxy. So what we're going to do is to create a new widget called galaxy. And I'm going to mark it stateless for now. So I do my class galaxy. It's going to be a stateless widget because it doesn't hold any data. And I need to override its build method that returns a widget so we know what to paint on the screen. So we do that, widget build, we take a build context as a parameter, and there we go, right? And here, what we're gonna be doing is simply to, for example, return a, we're gonna put it in the center, right? So the way we paint things on the center is by using the center widget, and we're gonna be building a shining star, okay? So now I need to build my class shining star. Whoops. Extends stateless widget. Override. We do the same thing again. Widget build. Build. Oops. Context. Context. All right. And now inside this build method, right, we're gonna be painting this star in the center. So what we need to be painting is we're gonna be creating a container, right? But this container now is gonna be a little bit special, right? Because it's gonna take, for example, the decoration of the properties of the star, right? So in the decoration, we're gonna use box decoration, right? We're just gonna be kind of like adding some effects to this star, right? And its color, it's gonna be, wait a second. We need to actually pass the star object, right? So we're gonna be passing in here a new star, and this shining star needs to receive as a parameter a new star, right? And now we pass that in the constructor. So shining star, oops. And it's gonna be taking this star as a parameter. So now in here, I can do this. I want the decoration of this container to be the color of my star, right? I want the shape of this container to be box shape, that circle, right? Because we want to draw circles. We're assuming that a circle is a star. We're going to be using a little bit of our imagination, and we're going to give it a little bit of height, 160 pixels, and a little bit of width, 160 pixels, right? If I look at this warning, it says that, hey, you can optimize this a little bit by putting that as constructor, right? And then on line 18, we can actually make this a constructor as well. Galaxy, and actually we can even do this. This key is just an identifier, but I can remove the const keyword from that. I'm gonna format this code, and let's run it again. And now we should see in the center of the screen, when it runs, a random star. We don't know what's gonna be its color. There you go. Impressive, right? This is the most beautiful star I've ever seen. It's not that impressive, I get it. It's just a circle on the screen, right? Like I assume that is not that impressive, but the idea here is that now we're gonna start animating the properties of this star, right? Like the universe is in constant change, stars come and go, they create, they die, right? So we need to introduce a little bit of chaos in our galaxy, even if it's just with one single star, right? So in order to do that, we're gonna introduce two things. A button that every time we tap that button is gonna animate the properties of the star, right? And then we're gonna learn a little bit about animations, how we can animate the properties of this star. So let's do it. We're gonna be doing in here is actually, because we're gonna be changing the state of our galaxy, turns out that one of our widgets cannot be stateless, right? We need to introduce some sort of state to understand what's the data that we hold in this galaxy. So where we're gonna be introducing that randomness, that element of state is gonna be in our galaxy object. So what we're gonna be doing here is that I'm gonna be commenting this for a second, and we're gonna be repeating the same thing. We need a class galaxy, but this time is gonna be an stateful widget, right? This galaxy now it's gonna hold some state, so we can animate its properties. We can change the galaxy. We're gonna be still using our constructor over here. But instead of painting now things on the screen, right, we need to create the state of this galaxy. So our API this time, what we're gonna be overriding instead is that we need to provide actually a galaxy state, okay? And that the way we do that is by calling this create state method, and we create the galaxy state. Oops. Actually, one thing to consider in here that you might be realizing like, hey, this object, in reality, what we have to return is a state object. So what we're gonna be doing is now creating that galaxy state, right? That extends the state object that is gonna be associated with our galaxy, right? So this is how these two are related now. This galaxy is a stateful widget. It has a state. We need to create its state. And the way these two are connected is by this create state method. And then by having this state object, its generic type is going to be associated with the stateful widget that we want to associate it to, right? So state galaxy ties back to your galaxy. And now, as any other widget in the world, we still need to paint things on the screen. So we're going to be overriding the same method that we saw before, our widget build method. So we receive the same build context, right? And now we gotta paint those things on the screen, okay? We said that we wanna put a button, right? When we saw the solution first, we put that button in the center of the screen. I still wanna keep that button in the center of the screen, right? It was on top of every single or any other object that we had on the screen. And then underneath that button, we had all of our stars, all of the galaxies, right? In order to put things on top of each other, we're gonna be using a new widget called stack. Stack allows us to put things on top of each other over a C index, right? So that's what we're gonna be doing here. We're gonna be returning a stack widget, right? This stack widget actually takes a child. No, it takes a children, right? Because it can have many widgets, right? Like we're putting one on top of the other, right? So inside of these children, the first object that we're gonna have, right? Like the one that is gonna be at the bottom of that visual stack is gonna be that center shining star, pretty much what we have in here, right? And the second widget that we're gonna have is gonna be another center widget, but this time it's gonna be a text button, right? A text button is what it says. It's a button in the shape of text, right? So it's gonna be tappable. We're gonna have text that is tappable, right? And what we can do in here is to add a child, and that child is gonna be a text object. And that text could be create a new galaxy. And then we need to pass the action. What do we do when we press this button, right? So in this case, we're gonna be using the onPressed API, right? And this is gonna be a Lambda. And inside this Lambda, we're gonna introduce what we wanna do with this, right? And in reality, what we wanna do is just to recreate, to build a new star, right? In order to do that, to repaint ourselves, we're gonna be using a new method called setState. And this setState, what it's gonna be doing is telling our widget tree to repaint itself. And we can paint as many times as we want, right? So by the time we call setState, we're gonna go to our widget tree and trigger again our build method. So we paint things again. And because we're painting things again, we're gonna be building a new shining star with a new star object. And that star object, if we see the implementation, it's taking, or it's assigning to its color property a random value every time. So let's give it a try. Let's run this code. And if we run it, we have our button in here. I'm gonna be changing the look and feel of this in a second, but if I tap it, hey, guess what? Now it's a little bit more interesting, right? Like this galaxy is much more cooler than the one we had before. It changes, right? Still one star, but it changes, right? So let's theme that text a little bit better, right? And in order to do that, we can change the property of the style, and we're gonna be doing like, hey, from the theme that we have, let's just go to the text theme and let's use like a big headline. So we're gonna be using headline large, and we're gonna modify its color. So we're gonna be copying those properties, and its color is gonna be colors.white. All right, that's very long. Dart is null safety. So when you retrieve themes from the theme, if you didn't set up the theme correctly, your text theme might be nullable, right? So we use this exclamation mark to say like, I know for sure that this is not gonna be null. So just unwrap its value and just give me the non-null value. How do I know that the theme is set correctly? Because actually this widget material app is setting up the theme for me and I don't have to do anything. If we were not using this widget, then I would have to set up the theme for myself as well, right? So now if I run this, we should see the text being much larger and in white. There we go. So now every time we tap on that, we see always, remember, we're changing the color, we're changing the alpha channel. That's why it seems to be kind of like we're iterating over 3 colors and then over 256 values of alpha channel, right? So that's where we're getting these new circles. But there's no animation in here, right? Like this change is very abrupt. I tap the button and I get a new color immediately. But the galaxy that we saw at the beginning, it was a little bit more fluid, right? It was more kind of like animating, kind of like very exciting, right? So we're gonna add a little bit of animation. In order to add animations in Flutter, there's 2 ways. And this is weird to say, but there's an easy way and there's a hard way. And we're gonna do the easy way because we like it easy, right? There's something called implicit animations, that there are widgets that are special that actually hide all the animation complexity for you. So you can just animate, right? And in this case, what we want to animate is the transitions between colors, right? If we go from orange to white, we know that there's an entire kind of like set of colors in between that we could be animating, so it feels a little bit more smooth, right? So let's do that. We need to change our shining star object, right? And in this case, instead of using a container, we're going to be using a special type of container called animated container. Boom, that's it. That's all we need. Actually, that's not all we need, right? If we look at the error message that we get in here, it says the name parameter duration, it's required. So we're going to add a duration because guess what? Animations, they can be of 2 types. Either they're infinite, right? They never end, or they can have a start, like a beginning and an end, right? Then animated containers is we're trying to transition from one color to another and then stop. We need to give it an animation. So we're going to give it an animation. And guess what? There's a duration object. And in here, we're going to add it like, let's say 3 seconds, right? Seconds. So with this, now we could animate. What are we going to be animating? Because we're not saying in here where we're animating, right? Well, we're doing that, right? As you remember, we're still calling set state. So that's going to repaint our widget tree. And this widget animated container is really smart. It's looking at all the properties in the container. And it's kind of like doing a delta between what we had before and where we're going now. And then trying to determine what's the curve between those 2 values, right? What is changing in between paintings here is this star, that color property. Therefore, it's going to animate our color between those 2 values. So let's give it a try. Let's run this. And let's give it a try. Hey, there we go. It wasn't very obvious this time, but now as we transition to a different color, you can see how kind of like it blends a little bit into the next color, right? It transitions from like this yellow to this gray. It takes 3 seconds, right? And if we wanted to play with the curve, imagine that you want the colors to bounce or something like that. Actually, animated container has an API called curve. Or maybe I'm just making that up. But you should be able to modify the curves that you want to use. I'm actually happy with this curve because what I want to animate now is other properties, right? We know how to animate color, but what if we wanted to animate size, right? Like remember that our stars, as they were moving in the galaxy, they were also changing its size, right? So let's try to jump into that. One of the things that we wanna modify in our star is the size, right? So we're gonna be adding a new property here called size. It's a double, right? Like primitives in Dart are very similar to any other languages. We have ints, we have doubles, we have strings, we have chars, whatever is needed, right? So our size object now, it's gonna be, again, random, right? So we're gonna get the next double that we can get from the random object, and we're just gonna add some like weird math in here, whatever. Multiply by 160 plus 5. That's just so we add a little bit of element of size to this object. But in reality, what we're getting is a new double value every single time. So if I wanted to change the size of this star, would someone want to venture what would be necessary to change the color and the size at the same time? Now that we've added this size field to our star? The answer is here, right? We have our shining star, and this animated container, remember, I said that it's gonna look up every property that we have underneath, right? Every property that we have in this widget, and whatever changes between paintings, it's gonna be animating that, right? So in reality, what we wanna change is this height and this width to be actually star that height, sorry, size, because we're assuming that it's the same size, and the width is gonna be our star that size again. So if I run this, just with the same animated container, we can animate multiple properties, not just the color, but the size, or if we wanted to animate, for example, the borders. In this case, it's always a box shaped that circle, but imagine that you wanna rotate from a circle to a square to a triangle to whatever that is. You can do that as well without having to change your animation code, right? So if I tap on that, it's not very noticeable that it's changing the size, but now we can see how this size is changing as well, right? So now that tiny circle that we had at the beginning in the screen, we know how to animate it and make it a little bit more exciting, right? We have now a single star in the screen that can change its color, both the color and the alpha channel, right? It can change its size as well, just by using one single animated widget, right? Any questions so far? All right, so the next solution, in reality, now that we know how to animate one, there's two things left. How to move this star around the screen. And once we know how to do this with one, guess what? We can do that with 200 stars very, very easily, right? So let's get started with that. Like, I'm not gonna lie, I have a cheat sheet here of the things that I have to do. So let me take a look that I'm not missing any properties or anything. Okay, awesome. So now we're gonna be changing the position of this star in the screen, right? So we're gonna go back to our star object, and now we're gonna be adding a new property called alignment, right? The alignment, think about it as the coordinates of this star in the screen, right? So we're gonna be doing that alignment, and we're gonna give it a value in the constructor, right? So our alignment property is gonna be an alignment object, right? And because we're saying that it looks like coordinates, is gonna take two values, right? Those two values are gonna be random as well. So we're gonna take the next double, and because double goes based on the values that it gives us, and we want to keep the stars kind of like contained within the screen, we're going to be just doing this math. Nothing special about it, just to keep these objects in the screen. But with this now, why is this complaining? You know what? Thank you so much. You know what? Thank you so much. Um, so through this context object, you can always calculate like what's the amount of pixels that you have available in the screen, what's the size that your parent is allowed you to be drawn onto, things like that. In this case, in concretely, right? This is just kind of like this alignment object. If we can look at the documentation, creates an alignment. Okay, not very useful. But yeah, pretty much through this math that we have in here is like rotating through all the possible coordinates that you could have within the screen available here, right? We're going to be combining this with a widget that takes an alignment object and knows how to interpret that information. Sorry? Well, in reality, what I'm trying to do is like if I wasn't doing that math, you could have, for example, like part of the star out of the screen, and I don't want that to happen. So we're not going to have any screens, any stars cut off. Let's not focus that much on the map. On the math, it's important actually. It's just the painting, not the map. But we can come back to that in a second. All right. So now that we have this, right? What we want to animate is, now that we have the alignment property that serves as the coordinates of the star, we want to animate its position in the screen, right? So what we're going to be doing is actually, I'm going to cut this for a second. And we're going to be introducing is a new animation widget, right? In this case, it's going to be called animated align, right? Actually, let's take a look to the documentation of this. It might be interesting. But this animated align, it says it creates a widget that positions its child by an alignment that animates implicitly. So as you can see, it's going to be taking an alignment property, curve, and again, a duration, right? So let's do that. We're going to be passing a duration. And in this case, because we want to have the same duration for the changes in size and color and the alignment as well, we're going to be extracting here as a variable, as a constant, right? So our duration is going to be seconds. We said 3, I think, yeah. So now we assign that to animation duration, right? We're going to give the alignment. If I can type this word properly, my goodness. Star alignment, right? That's the alignment that we were just building for this object. We're going to give it a curve. So in this case, we're going to be using curves. I don't know, whatever you want to pick from here. I'm going to be picking is in out just because I like it. But if we wanted different type of curve, we could use that. We could even create our own curves, right? In case you want to, I don't know, do whatever crazy things that you want to do, right? And now that we are animating the alignment of our star, remember that I cut the code that we had before. Well, we're going to pass it here. I'm going to add a comma to that, and I'm going to use the animation duration object here, and we can remove that. I'm going to format this code. So we have our galaxy. We don't need this anymore. Our galaxy is a stateful object. So every time we tap this create new galaxy, now what we should be getting is a new star moving all around the screen. Let's run it. All right, it's doing its work. Hey, now our galaxy is not in the center anymore, even though, right, we're using sorry, even though we're using this center object in here, right? That center object now takes over the entire space, right? But what we paint inside might not be aligned in the center anymore because we're changing the alignment, right? So if I tap that, we move this star all over the screen, right? And as it moves, it's changing its size, its color, and its alpha channel, right? It's all random. I don't know where it's going to go next. We just know that, hey, this is how the universe works, right? There's a little bit of chaos in these operations, right? So now that we know how to do this, right, in reality, we should be able now to go to 100 stars, let's say, right? So in order to do that, I purposely commented that code. So we're going to remove this galaxy, right? And instead, we're going to be using one that is going to be taking a number of stars property, right? That number of stars is going to be a parameter that we have to pass in the constructor, number of stars, because we have it here as a name parameter. We're going to be passing it inside these brackets. So what we're going to be using in here is like, we're going to mark it as required, and we're going to be like, just assign to this name parameter, assign it to this property, right? And I need to pass the super over there, right? And now we need to hold our stars. So inside my galaxy state, I'm going to be building an array of stars, right? And I'm going to be, even though it's marked as final, that means like it's immutable. What it's immutable is the object, but not the content of the array. So now every state object besides the build method, right, it has a life cycle. And that life cycle is going to be telling you a few things. It's going to give you an init state life cycle method. So in case you need to do things by the time you initialize the state, you can do so, right? Like you might need an initial state to paint on the screen, right? Then you're going to have access to your build method. That means paint on the screen. Finally, it might tell you when you're going to be removed from the widget tree. That would be a dispose method in case you need to do any cleanup in your state, right? In this case, we're just painting things on the screen, but sometimes you might be accessing some sort of database, some sort of like reactive connection, right? That if you keep alive, you might have memory leaks. Therefore, having access to a dispose method might allow you to do whatever cleanup operations you might need at that point. So what we want to do now is to, based on this number of stars, right, build an array with all those random stars, initialize that in our state, and then paint them in the screen. So what we're going to be doing here is inside our init state method, right? We're going to call super init state. And then we're going to be doing is like, hey, we're building a new galaxy. That's the big bang, right? So we're going to be creating a new method called big bang, right? And this big bang method, what it's going to be doing is just to clear the previous value of our star, of our array of stars. And then what we're going to be doing is a for loop that goes from, my goodness, I don't know how to write for loops anymore. It's going to start at 0. Then it's going to iterate through the number of stars that we gave to our widget, right? So the way we access that, because that property was given to the widget and not to the state, inside the state object, you can call this widget property and it will give you the property of the widget associated with it, right? So widget that number of stars, and then every time we loop, we're going to increment an array, like our index, sorry. And every time we do that, we're going to be adding a new star to our list of stars, right? Remember, every time we create a new star object, it's a random star with a new alignment, with a new color and a new alpha channel and a new size, right? So that's how we create all those random stars from that. And what we're going to be doing here, right? First of all, we need to modify this. We need to modify this because now what we need to do is to paint 100 stars, not just a single one. So the way we're going to be doing this is that the stars themselves, they are going to be building and being painted on top of each other, right? Like this is not 3D. We still have like a 2D representation of the stars. So what we're going to be doing is paint one. Once that one is painted, we go to the second one, gets painted on top of each other. And just like that until we reach those 100. Once we finish, then we're going to be painting the text, the button on top of that, right? So we're going to be building inside that stack another stack widget that takes a children property as well, right? And inside that children, what we're going to be doing is another for loop that says for every star that we have in our stars list, right? Then build a shining star that takes that star object that we have in there. This looks good to me. I'm going to add that trailing comma. Thinking here, what we need to do is that every time now that we change our state, before what we were doing was just like paint a new star, right? But because now we are calling Big Bang in our init state, right? We're initializing those 100 stars. What we're going to be doing is like every time we call set state, we're asking to repaint everything again. Instead of just repainting everything again, we need to actually clear our previous array of stars and build a new one, right? So what we're going to be doing inside this set state method is just to call Big Bang again. And actually, I can leave it like that. So it's easier to understand, right? And then one of the things that I'm going to be changing here is that this animated align widget, we're going to be returning in new one called position field. That takes a child. We add a comma there and all the stuff. This position widget, if we look at the documentation, what it's giving us is just because we're building all these objects and not just one anymore, right? Like it's changing the position around the screen. So pretty much what it's saying is like, don't use the previous alignment that we had for the previous object, just reposition yourself and you have the entire field space to do so as well. So if we click on run here, we should see initially that we have now about 100 stars that we gave it here. Moment of truth. Ooh, there's definitely 100 stars. All right. So it did work. Oh, you know why I think it looks so big? Because I made the, as I made the font bigger, and this is not an IDE, it also increased the viewport and all that stuff. So let's go here. You can change this. Let's do this. Let's see what happens. Since that's the size, we're going to make our stars a little bit smaller, but because it's zoomed in, that's what's going on here. Hey, a little bit better, right? So before we had one star that we were moving all around the screen in random movements, right? And as it was moving, it was changing its size, its color, and its alpha channel. Now we did the same thing, but with 100 stars that we're passing here, right? So we're calling this Big Bang method that is building 100 stars every single time, right? And painting those in the screen. And when we tap the create a new galaxy method, just for 3 seconds, it's pure chaos, right? It creates 100 stars again. It animates them to random places in the screen, changing its position, changing its size, changing its color. Just pick one in the screen, whatever you want, right? For example, I'm going to try to follow this one. And once I tap the button, if I follow it, it went all the way over here. And now it's a little bit bigger, almost transparent, right? It just changed into something very, very different. So just with about 126 lines of code, right? We were able to build complex animations, more than one, actually. We're animating 100 objects, multiple properties at the same time with our browser. We're not using any IDE. I haven't installed anything special in my computer. I'm just using Safari, right? Uh, and this is just an experiment. It's just for fun. I use this to teach animations, right? But if you want to build applications like the one for BMW, you can do that as well, right? This is where like we're talking before about material. There's like a catalog of widgets that you can use, right? If you use your Google Home devices, they're built with Flutter, right? If you are like, I don't know if there are any Hamilton fans here in the audience today, but like if you've seen the musical, the mobile app of Hamilton is actually done with Flutter as well, which was kind of like the first major application done with Flutter. I recommend you to install it and enter the lottery. You can get free tickets to see Hamilton. It's great. If you've played games via Stadia, right? Like I don't know if you've played video games through that cloud system. It's done with Flutter as well, right? It's very, very powerful. It's not just for mobile apps. As I said, anything that anywhere where you see on a screen, you can use Flutter. One of the most exciting projects that I've ever worked with, right, is that my company actually is helping Toyota to build their Flutter products, but this is not for the phone. Like Toyota is actually investing in Flutter to run that in their vehicles that are going to be in the market, right? So the navigation system, the instrument cluster, all the self-driving capabilities, all that's going to be done through Flutter as well. So it's a very exciting platform. It's very developer friendly. The community is really like warm. It's really supportive, right? There's tons of events all around the world, right? So hopefully with this, I went really, really, really fast, and I glanced through a lot of hard concepts that, of course, I kind of like took for granted because I just wanted to show you the result. But hopefully this has sparked your curiosity to keep building something in your own time, right? Like if you want to check the website and see what's there, see what companies are using Flutter, right? If we go to many of these kind of like learn development and all the stuff, there's a lot of tutorials, right? So yeah, that was my goal. We built an entire galaxy in 45 minutes. I'm in time even. My goodness, I'm gonna sleep so well tonight. But yeah, that's what I have for today. Any questions or anything?
It appears the stars are partially transparent. Why? And how to control that?
That's a really good question. We have our star object here, right? This star object is just pure data. It's not a widget. It just holds information about the star, right? The properties of the star are color, size, and alignment, right? So within the color, once we assign it its value in the constructor, we're doing two things, right? We're picking one random color from this array of colors. It could be yellow, white, or orange. And once we have the color, we're modifying its alpha channel as well, right? The alpha channel is what controls transparency because it's part of the RGB colors, right? Red, green, and blue. The alpha channel also has the same range of values that goes from 0 to 256. I'm going to be honest, I never remember if 0 is transparent or opaque, but I know that within that range, one means it's like fully transparent, the other one means it's not transparent at all, right? If we look at the galaxy that we have in here, you can see how some stars, they have some transparency and they overlap on top of each other, right? That's because we're building them as a stack, right? So once we paint the first star, then the second one goes on top of each other. And if they happen to share some coordinates, well, we see that overlap of colors in there. But the transparency itself, it's coming from this alpha modification here.
Okay, and I have some questions. And of course, we always have time for other questions from the audience. And I want to say that I was hoping to learn more about Flutter on my own beforehand, but that's one of the great things about these meetings is that you can go and within a short amount of time get more information than you probably would be motivated to do on your own. So my questions are, so I'm involved with teaching game design and scripting, and I use Unity, which is kind of a big framework. I saw that there were some game engines that were built on Flutter. I don't know if you have any favorites.
Oh, that makes me so happy that you asked me that. So one thing that I didn't say about myself is I'm the head of engineering at Very Good Ventures. We're actually an agency dedicated just to build Flutter products, and many products in the Flutter industry are games. Flutter, there's this beautiful framework called the Flame Engine. It's a 2D gaming engine. It actually, one of my teammates from Brazil is the main maintainer of this framework, right? And I don't know why the website is not loading. I've seen it. I promise that it works. So if you want to build games for Flutter, the Flame Engine is the starting point. Now, Google I/O was last month in May, and one of the projects that we built for Google I/O in collaboration with Google was this Pinball project. So let me see if I can find it. It's actually open source. So there's a few things I'm going to share with you. This is the game itself. Hopefully it loads, but it seems like the network is not being my friend here. All right, maybe it's blocked or something like that. But if we Google Flutter Pinball, the first result is this I/O pinball machine that it's built purely with Flutter, right? Very different than what we've seen today. But also the beautiful thing about that is that you can see the code fully open source here under the Flutter repo. It's super cute, first of all. The Flutter mascot is Dash. It's a bear. We have Android. We have the Firebase mascot, right? This project was built by Very Good Ventures, right? And then on top of that, there should be this Medium article that explains how we build this game. We have the privilege of being kind of like very well known in the community for kind of like the products that we build, the quality that we provide, right? We have a huge focus on testing and automation in our products, right? So I definitely encourage you, if you're interested in gaming, to take a look to this repository, because it shows you how we control state management in games, right? How we actually unit test and widget test games as well, because this is also a website, how we automated releases. It's all open source, right? So you can fork it, run it on your computer, you can open issues, right? It's a very, like, even though we put the initial effort, this has been also like a community collaboration. So that has been great to see. But yeah, this Pinball project is one of the big ones in game. If we go to the Flutter documentation, one of the announcements as well was this game section. So the Flutter team at Google, they introduced this idea of Flutter Casual Games Toolkit, that it's kind of like a Kickstarter of how to monetize your project, how to include kind of like the scaffolding of what every game needs, and how to get started with Flutter.
And I think we have a follow-up question here from, so it seems, I think the answer is yes, but is Flame Engine open source?
Yes. So we go to GitHub Flame Engine, and I realized I usually try to wear some merchandising to events like this, and I have a really cool Flame hoodie. But of course, in Chicago right now, it's not like hoodie weather. But yeah, if we go to GitHub, there's an organization called Flame Engine, and they have the Flame repo. But like, not only that, they have a few other kind of like, they have like access to Forge2D, right? It's this kind of like a backport of the Forge2D also that they have for JavaScript, right? Like many other kind of like repositories and all the stuff, but they have the Flame Engine. It's fully open source. There's multiple examples, right? Like if you want to build your like RPG games, it's perfect for that. We build a pinball game, great for that. I've seen like air hockey. I've seen, I don't know, Flappy Bear. Actually, I've seen Flappy Bear, but for Hamilton, so it's Iron Bear. It gets tricky, but yeah, there's a lot of kind of like community effort behind this. Actually, many of my teammates, they're active maintainers of this repository as well. So if you have any questions even about that, just feel free to kind of like find me on Twitter or LinkedIn or whatever, and I can point you in the right direction. But yeah, there's a big kind of like level of energy right now around like 2D games in Flutter.
Okay, my last question here is, if you didn't have Flutter, what would you use?
Well, Alvin actually can talk a little bit about that. Prior to this, I was kind of like the team lead for Android at BMW for many years. Like, I love working with user interfaces. My mind is very visual, and I can understand very easy. Like, oh, if you tap a button, this is the journey of the data and how you process it back, right? So I've been building websites for many years, iOS apps, Android apps, right? And I spend a lot of my kind of like years as an individual contributor just working with Android, Java, Kotlin, all that stuff, right? It bothered me always that there's like this idea of you're building apps and you have iOS and Android, and as an organization, it's like two teams double the cost just to build the same product, right? That's a problem, for example, that cloud teams don't have, right? It's like it's much more efficient, much more streamlined, and but at the same time, every time I tried like some sort of cross-platform solution, whether it's web, trying to embed like web within an app, right? It's not the same experience. And in this case, the penalty is paid by the user, right? You have loading times, it's not as smooth, right? I tried Xamarin. In that case, the penalty is paid by developers because it's not a great developer experience. And on top of that, you still need to actually know iOS and Android. So that wasn't great. A framework that has been very popular in the last few years has been React Native, right? It's been developed by Facebook, and React Native is quite interesting, right? Like if you have an organization that is familiar with React and how that works on web, you can bring some of the same concepts to mobile development, right? Not entirely the same, but at least you don't need to train again an entire organization. The problem with React Native is that as you scale your code base and your practice, there's two penalties that you pay. One is at the performance level. The way React Native works is that it's not a compile solution, it's an interpreted solution at runtime. Therefore, at runtime, the more code you write, the more you scale, right? Like you see that you're starting like dropping some frames, that the animations aren't smooth, right? Things like that, right? Then on top of that, I think that bringing kind of like the node experience to mobile, at the end of the day, it's really hard, and that affects also the developer experience, right? With Flutter, one of the things that I have to give credit to the Flutter team is that I think that they solve the developer experience problem. Like those widget APIs are what like React developers love about props, right? Now you have it with widgets, right? The user doesn't pay a penalty. I actually have run like user studies in which I actually have this data at some point. I have to make it public, but we ran this study with about 300 users. 65% of the users said that the Flutter application was more performant than a native application, right? The reality is like if it's done well, you cannot tell. You don't drop any frames, their animations are equally smooth, but now you can target multiple platforms, right? So that's the benefit in there. So if we didn't have Flutter, I would still try to go native because the other solutions, they feel more like a patch, right, than a scalable solution, right? With Flutter, the reality is like they were not trying to go and target the cross-platform problem. They were trying to be multi-platform, period, right? They have a product that works really well, that is Google Chrome. So what they did is remove everything that is not necessary from Google Chrome, get it down to the bare bones of what it means rendering pixels on the screen, and then use that rendering engine to build the Flutter APIs on top of it, right? So painting is super smooth. It's a very little overhead when it comes to compilation and all that stuff. It's a very elegant solution, right? Now in the future, will we have something better? Absolutely. Technology, that's a beauty of technology, right? But it's a very well thought out framework.
Okay, so maybe a follow-up to that, Jorge, maybe you already answered this or so, that is this like Chrome OS then?
No, not necessarily. Like Chrome OS is a very different thing, but if you've heard about this thing called Fuchsia OS, right? Like this is what no one knows what it is, but everyone has an idea of what it is, right? Google is working on this operating system that is supposed to target every device, whether it's IoT, computers, phones, whatever that is, right? There's lots of rumors about this could be the replacement of Android or not. We don't know, right? But the reality of Fuchsia is that the way you're going to be building applications is with Flutter, right? So even if you want to get ready for the future, learning Flutter these days is a good investment for the future as well. But it's a little bit different than Chrome OS, right? Chrome OS is based on web, and it uses like HTML5 technologies. Flutter is something different.
Okay, and also related, you mentioned about for optimization. So I saw something here in the chat. Isaiah asked, like, but by having two teams, you can optimize for each platform. How would you answer that? All right.
Well, so with Flutter, you still have the ability to talk down to whatever, like it's the low-level platform, right? If you need to access the camera feed, the GPS, or all the stuff, right? You still can do that. Flutter offers the idea of plugins. They have this concept of federated plugins that allows you to build like an Android package, an iOS package, and provide like a common Dart interface to handle the communication, right? So at the end of the day, if you need to build something at the native level that is not painting, right, you can still do so. But then the thing is like you package that in plugins and you can share that, make it open source and be a little bit more efficient.
Okay, and thank you. And then another question here is that in Dart, are objects allocated on the heap like Java or on a stack like C++ or Rust?
Wow, you got me there. So, sorry about that. I've been spending too much time lately on spreadsheets and less on that. I don't know the answer to that at this moment. Sorry.
Okay, so maybe we'll get back to that maybe sometime later or so. Okay, yeah, this is great. Thank you, Jorge, for this presentation, and also thank you for showing on the Flutter my BMW app on the on the center of the of that screen. I mean, that's really good.
I didn't pick that, but this is just fun fact. This is where like Alvin has spent a lot of time, and I did spend a lot of time working on this app. So it's funny to see it here.
Yeah. Okay, great. Well, thank you, Jorge, for that. Before we end, I'm going to launch a poll for those people that are online. If you can answer those questions, that would be great. And then I'm going to go ahead and share my screen. All right. So, yeah, so next month's presentation is going to be in July the 20th. And it's going to be virtual, so it's not going to be in person. And we're going to have Nikita Sharma, who is at Veil Systems, and is going to be talking about automatic speech recognition and overview. And it's already up there on our meetup site, so you can go ahead and start signing up for that. And like I said earlier, if you go to our YouTube channel and subscribe there, you can see all the list of previous meetups and webinars that we've had. So if you missed other ones, you can go ahead and go ahead and see those. Also, as well, we're looking for volunteers to help to join us for ACM Chicago. So if you have any experience in writing, planning, videography, audio editing, or networking, we're always looking for other speakers and other topics for our events. So please let us know. And we're also have some elections opening. So in our next, we're pretty much the end of this kind of year or so, and we're gonna have one in July, and then our next year starts in September, and we're gonna have elections for treasurer, media communications chair, vice chair, and chair. So if you want to help out with ACM Chicago, you want to bring something back to the Chicago ACM community, please reach us, and then we can have you be on the ballot or so when we go ahead and do the election. And so you can just go ahead and email us, so vicechair@chicagoacm.org, and also chair@chicagoacm.org. All right, well then, thank you very much. Thank you, Jorge, for being here this evening in person. Very, very cool. Showing the stuff on the Flutter. I'm really impressed how you're able to go ahead and code that fast, just on your computer. So that's really good. But anyway, thanks to everyone, and enjoy the rest of your evening. And oh yes, and also as well, for those people who need to have a professional development hour credit for your professional engineering kind of certificate or so, then you can get a PDA certificate, and we will email the link for that to get that PDA certificate. And also we'll email as well the when we have the YouTube video ready. But if you subscribe to our channel, then you'll be able to see that. All right, so thank you very much. Thank you, Jorge, and we'll see you either in July or we'll see you in our next event after that. All right, thank you very much, and have a good night.